Hi and welcome to module number 5, which is about adding a compute layer using Amazon EC2. This is a Amazon Cloud Architecting certification and we are covering the knowledge check questions. So let's try to read the first question and explain why the selected answers are the right answers. So first of all, question number 1 says that which attributes are reason to choose Amazon EC2. So the right answers for this one, first of all, I'm selecting complete control of computing resources. The reason for that is that when you choose Amazon EC2, you get full control over your virtual servers, meaning that you decide the operating system, software, networking setup, and even the security configuration. This is perfect for organizations that want to manage everything themselves rather than using managed services. The other right answer is the ability to run any type of workload. This is correct because EC2 is extremely flexible. You can run virtually any kind of workload from small websites to massive enterprise databases or AI models because AWS offers so many instance types, storage options, and configurations. Now let's see that why other answers are not the right answers. Now if we'll select the AWS management of operating systems security, this is not the right answer because you manage the operating system security on EC2. AWS secures the underlying infrastructure, but the guest operating system and operations are your responsibility. If we'll see ability to run serverless applications, no, EC2 isn't serverless. For serverless workloads, you would use AWS Lambda or Fargate. EC2 still requires you to manage the servers. And if we look at the last option, AWS management of operating system patches, again, that's up to you. AWS doesn't patch the EC2 instances. You handle the operating system updates and security patches manually or through automation. Now question number 2, what are the benefits of using Amazon Machine Image? So there are 3 correct answers for this one. The first one is selling or sharing software solution packages as an AMI. The reason for that is that you can actually package and distribute your software using AMIs. This is how companies sell pre-built images in the AWS marketplace. It's an easy way to share and monetize your setup. The other right answer is using AMI as a server backup for Amazon EC2 instance. An AMI acts like a snapshot of your server. You can restore it or launch new instances from any time, which is really useful for backup or disaster recovery. The third answer is launching instances with the same configuration. One of the best features that you will get in AWS, you can launch multiple servers that are identical to each other. That ensures consistency across environment like development, test, and production. Now let's go through the other answers. For example, the first one over here is migrating data from on-premises to Amazon EC2 instance. Now, this is wrong because this is not what AMIs do. For data migration, AWS offers tools like DataSync or Snowball. And we are not selecting automating the security group settings for instances because security groups and networking configurations are not part of AMI. And we are not selecting updating system by patching their AMI. You can't patch AMI, it's a static image. To update, you'd have to create a new AMI with the latest patches. Question number 3 says the system administrator must change the instance type of multiple running Amazon EC2 instances. The instances were launched with mix of Amazon Elastic Block Store, which is EBS backed by Amazon Machine Image, and instance stores backed AMIs. Which method is valid and why to change the instance type? So the right answer for this one is to stop an Amazon EBS backed instance, change its instance type, and start the instance. The reason for that is that this is a supported process for the EBS backed instances. You must first stop the instance, then modify the instance type, and finally start it again. Because the root volume in EBS, your data and operating system remains intact across the stop and start cycles. Now let's go through the other answers. We didn't select change the instance type of an instance store backed instance without stopping it because it's not possible. Instance store backed instances cannot change type while running, and they don't support their required stop, modify, start during the workflow. The other option was to stop an backed instance, change its instance type, and start the instance. That's wrong as well, because invalid instance store backed instances cannot be stopped, only rebooted or terminated. To change the type, you'd have to relaunch a new instance of the desired type and reconfigure from your image to setup. This option's workflow isn't supported here as well. And if we look at the last option, which is change the instance type of an Amazon EBS backed instance without stopping it, we are not selecting it because you must stop an EBS backed instance before changing its type. Changing while it's running isn't allowed. Now, question number 4, it says that a workload requires high read and write access to large local data sets. Which instance type would perform best for this workload? So there are two answers for this one. First of all, we'll select memory optimized. These instances are perfect when your workload needs to process large data sets quickly in memory, like real-time analytics or in-memory databases. The other right answer is storage optimized. They are built for heavy disk input and output, so ideal for applications that need fast read and write performance to local storages. Now let's explore the other options. For example, general purpose is not the right answers. These are balanced, good for everyday workload, but not optimized for high performance and speed for the data access. If we will see like compute optimized, it's not the right answer because those focus on the CPU performance, not storage and input and output speed. And finally, accelerated computing is not the option because these are good for GPU or specialized hardware tasks like machine learning or graphic rendering, not heavy read and write disk operations. Next, question number 5 is that an application requires the media access control address of the host Amazon EC2 instance. The architecture uses an AWS auto scaling group to dynamically launch and terminate instances. What's the best way for the application to obtain the MAC address? So the only right answer is to use the user data for each instance to access the MAC address through the instance metadata. That's the smartest way. Every EC2 instance has its own metadata and you can pull the MAC address directly from there. It's always up to the date and it doesn't need manual setup. Now, if we'll explore the first option, which says that include the MAC address in a custom AMI for each instance in the AWS auto scaling group, this is not right because the MAC address changes every time a new instance is created. And if we'll see the second option, which says that write the MAC address in the application configuration file for each instance, that's unreliable. Auto scaling creates and destroys instances automatically, so you can't hard code it. And if we'll see the last option here, which says include the MAC address in the Amazon machine image that is used to launch all of the instances in the AWS auto scaling group, that's not right as well because AMI don't preserve the MAC addresses because each new instance gets a unique MAC address. Question number 6 says that which statement about user data are correct? So there are two answers for this one. The first right answer is by default user data runs only once when an instance is launched. That's how AWS works. User data executes automatically during the first boot unless you configure it to run again. The second right answer is the cloud architect must remove the configure user scripts from the rerun the user data scripts. This is correct because if you delete the file, the next time the instance boots, it would run the user data script again. So let's see the other options. The first option was that by default user data runs after every instance restarts. No, it doesn't. It runs only once by default. And if you'll see the second option, user data cannot be run while the instance is stopped. That's wrong as well because it's irrelevant. User data runs when an instance launches, not while it's stopped. And if we'll see the third option, It says that the cloud architect must run the var library and then cloud instance script part01 command for the user data script to run it again. It's wrong as well because that's not the standard or recommended AWS method. Removing the configuration file is the proper way. Question number 7 says that a transactional workload on an Amazon EC2 instance performs high amount of frequent read and write operations. Which Amazon Elastic Block Store volume type is best for this workload? So the right answer for this one is provisioned IOPS SSD. So the reason for that is that this type delivers predictable high performance for inputs and outputs for database style workloads where consistency and speed are critical. They are perfect for transactional databases. Now let's explore other options, like if we'll see general purpose solid state drive. That's not right because they are good for general workloads but not for high intensity transactions. And if we'll go for the throughput optimized hard drive or hard disk drives, this is not correct because they are best suited for sequential data access like big data analytics, not frequent data read and writes. And if we'll see the last option which says cold hard disk drive, this is the lowest cost option for infrequent data access, but definitely not right for transactional workloads. Now we have question number 8. It says that it is possible to create an NFS share on Amazon Elastic Block Store backed Linux instance by installing and configuring the NFS server on the instance. In this way, multiple Linux systems can share the file system of that instance. Which advantages does Amazon Elastic File System provide compared to this solution? So there are two answers for this one. First is high availability. The reason is that EFS is built across multiple availability zones. So even if one zone goes down, your data stays accessible. You don't need to manage replication itself. Now the second right answer is automatically scaling. EFS grows and shrinks automatically as you add or remove files. There's no manual resizing like you would have with an NFS server. Now we are not selecting file locking. The reason for that is that that's part of NFS protocol itself, not a special advantage of EFS. Now, the strong consistency option is not the right option since both NFS and EFS already provide strong consistency. So it is not a unique option. And then for no need for the backups is not the right option because backups are still important. EFS doesn't automatically replace a proper backup strategy. Now in question number 9, which feature does Amazon FSx for Windows File Server provide? So the right answer for this one is that fully managed Windows File Servers, FSx is a fully managed service that runs natively on Windows File Servers. It integrates seamlessly with Active Directory and uses SMB block. So you get enterprise file sharing without managing the underlying infrastructure. Now let's see the available options. The first available option was to back up the solution for on-premises Windows servers. That's not right because it's not just backup service, it's a full file system hosted on a managed AWS. Then if we look at the Amazon Management Agent for Windows File Server, no agents are present here, so FSx provides the complete Windows File Server environment. And for Microsoft Active Directory Server for Windows File Server isn't the right option because it integrates with the Active Directory, but it's not an AD server itself. And finally, in the last question, which description of Amazon EC2 pricing options are correct? So we'll have to select two options. The first right option is spot instances offer spare compute capacity at discounted prices and can be interrupted. The reason is that spot instances give you massive discounts because they are unused AWS capacity, but AWS can reclaim them anytime. So they are best for flexible or fault-tolerant workloads. The other right option is that with on-demand instances, customers pay per usage time, no long-term commitments are required. The reason for that is that You pay as you go model, so you only pay for what you use and can start and stop anytime. Now let's see the other options. For example, the option for reserved instances are physical servers that are reserved exclusively for customer use. The reason is that it is incorrect. They are just pricing discounts for the long-term usage, not a dedicated hardware. The other option that we had over here was dedicated hosts or servers that are dedicated to one purpose, such as firewall. No, dedicated hosts provide isolated physical servers, but they are not limited to a single purpose. And then if we'll explore the last option, it says that saving plans are budgeting tools that help customers manage EC2 costs. Saving plans are commitment-based pricing models, not budget management tools. So that was our module number 5 on adding a compute layer using Amazon EC2.